Greetings. I had a request for a solution to problem 12 from module 5, and I wanted to remind you up front, you might be thinking, oh, I don't care about that. I already finished that problem set. If you didn't get 100% on this, go use the similar question button, and you can redo this problem and get a better score, potentially, depending on what you had to begin with. The similar question button is also useful for getting extra practice. If you have finished a problem set but you still don't feel like you understand the concept fully, you can always use the similar question button. So as we know, good problem solvers read the problem many times. So let's start. A probability experiment is conducted in which the sample space of the experiment is S equals the set containing those numbers. Then we have the event E is the set containing the numbers 8, 9, and 10, and we're assuming each outcome is equally likely. Meaning that if you grab one of these numbers out of a hat, you have just as good a chance of getting 5 as you do 12, which makes sense. So we want to list the outcomes in E complement first. And notice that the sentence says the outcomes in E complement are squiggly, blank, squiggly. That means that we're just listing the events. And so E complement is going to be the things in S, in this set of discourse that we're talking about, but not in here. So I'm going to start typing things that are in S. 7. I'm not going to type 8 or 9 or 10 because I want E complement. 11, 12, 13, 14, 15, 16. That's E complement. And sometimes we call it the relative complement because it is all of the things in the set that we're interested in, namely S, but not in E. And so we submit, and we're congratulated. Now the probability of E complement is the number of possible choices from E, 3, 4, 5, 6, 7, 8, 9, divided by 12 things. So what do we have here? We have, just want to double check this, 3, 4, 5, 6, 7, 8, 9 out of 4, 5, 6, 7, 8, 9, 10, 11, 12, 9 twelfths, but the system wants a simplified fraction, so I'm going to type in 3/4. And also, I want you to notice that you can use the complement rule here as well to get this figured out. So since there are 12 events total in S, the denominator is definitely 12, and 12 minus 3 is the probability, is the number of outcomes in E complement. So you could do that as well. So I hope this was helpful, and please let me know what you think in the comments. And if you have more requests for specific examples worked out, call, text, or email, and I will gladly do it. And thank you for asking, and I'm sorry it took me so long to get to it. As you might be able to tell, I've been sick and trying to fight it off, but I hope this was helpful.